In this lecture, we are going to discuss about the production of rotating magnetic field in three-phase induction motor. So in three-phase induction motor, the stator comprises of a three-phase windings. So those windings are displaced by an angle of 120 degree. So if a three-phase AC supply is given to such winding, it will produce a rotating magnetic field. So now let us assume that a three-phase induction motor with two poles has identical windings displaced at an angle of 120 degree each. Okay, so let phi 1, phi 2 and phi 3 be the fluxes and their positive directions are assumed as shown in the figure. So now we'll consider this vector diagram. Here phi 1 is the phase 1 flux in phase 1, that is R phase, and phi 2 is flux in phase 2, Y phase, and phi 3 is the flux in phase 3, that is B phase. Okay, each of these fluxes are displaced by an angle of 120 degree each. Okay, so now let phi m be the maximum flux and phi r be the resultant flux. So the resultant flux can be obtained by the vector sum of individual fluxes phi 1, phi 2 and phi 3. Okay, so now let us assume that phi r at 4 instants at 1 by 6th time period. So now we are going to prove that the magnetic field which is produced in the stator is rotating. Okay, so for that we are going to consider 4 intervals. So this is the waveform for the flux. Okay, so this is phase 1. Okay, this is for phase 2 and this is phase 3. Okay, so now we are going to divide this into 60 degree intervals. Okay, in order to prove that the magnetic field that produced is rotating in nature. Okay, so here at this instant we are going to assume omega t is 0. So along the x-axis we have omega t and y-axis is a flux. And then instant 2 is omega t corresponding to 60 degree, and instant 3 omega t 120, and instant 4 omega t is 180. So this is a maximum value of flux. So maximum value remains the same in all the 3 cases. Okay. So now we'll write down the formula for the instantaneous values of the fluxes. So this is similar to the instantaneous voltages we will write. Okay, so this is R phase flux in the R phase phi 1, phi m sin omega t. Okay, reference value. And phi 2, this is flux in phase 2 or Y phase. So phi m omega t minus 120. Okay, phi 2 lags phi 1 by an angle of 120 degree. Okay, similarly phi 3, phi m sin omega t minus 240. So this is similar to phase B, that is phase 3 or phi 3 we have taken here. So now we'll consider case 1. So case 1 is assumed as theta is equal to 0. Okay, theta is also called as omega t. So now we are going to substitute the value of theta in phi 1, phi 2 and phi 3. So we can write phi 1 is equal to phi m sin 0. Okay, here 0. So this value will be 0. Now phi 2 is phi m sin omega t minus 120. Here omega t is 0. So 0 minus 120. So sine of minus 120 is minus sine 120. So this is minus 0.866 phi m. Similarly, phi 3 is given by phi m sin omega t minus 240. Here omega t is 0. So this is minus sine 240. Okay, so that is equal to minus phi m sin 240. That will be plus 0.866 phi m. So now we have to find out the resultant flux phi r. So resultant flux is vector sum of all these 3. Okay, now we are going to find out the magnitude, and the direction we will find out by drawing the vector diagram. Okay, so now we'll here if we see phi 1 is 0, so we can ignore this one, and so the magnitude of phi r is given by under root of phi 2 square plus phi 3 square. So phi 2 square is minus 0.866 phi m whole square, and phi 3 is plus 0.866 phi m whole square. Okay, on simplification we will get 1.5 phi m. So this is the magnitude of the resultant flux phi r. So now we'll find out the direction by drawing the vector diagram. Okay, this is the reference value. This is a positive direction of phi 1, positive direction of phi 2 and positive direction of phi 3. So vector diagram as we discussed in figure 1. Okay, so now we are going to draw this phi 1, phi 2 and phi 3 for case 1. Okay, so in case 1 phi 1 is 0. Okay, we can neglect this. Now phi 2 is negative. Okay, phi 2 negative means this is positive. So we have to draw the negative value of phi 2 in the opposite direction. So exactly opposite to the positive of phi 2. So now we can represent this as minus 0.8665 m. Okay, its magnitude is minus 0.8665 m. Okay, so now phi 3. So if we see phi 3 is positive. Okay, so this phi 3 should be drawn along the same positive direction. Okay. So now we have to find out the resultant. So for finding out the resultant, we have to develop this parallelogram. So for developing the parallelogram, we have to draw a line parallel to this one and a line parallel to this one. Okay, so now we'll draw two lines, one line parallel to this, another line parallel to this one. Okay, now we have drawn the parallelogram. So the resultant of these two flux will give the direction of this flux phi r, and the magnitude already we have found out. Magnitude is 1.5 into phi m, 1.5 times the maximum value. So at omega t is equal to 0, this is the direction of the resultant flux. Okay, so now we'll discuss case 2. So in case 2, we have omega t is equal to 60 degree. So now we have to substitute 60 degree in phi 1, phi 2 and phi 3 equations. So phi 1, phi m sin omega t, or phi m sin 60. So that is plus 0.866 phi m. Okay. So next phi 2 is given by phi m sin omega t minus 120. Omega t is 60 here. So 60 minus 120 is minus 60. So sine of minus 60 will be minus sin 60. So minus phi m sin 60 will give you minus 0.866 phi m. So now phi 3 is phi m sin omega t minus 240. Here omega t is 60 degree. So 60 minus 240 is minus 180. Sine of minus 180 is minus sin 180. So minus phi m sin 180 will give you 0. So now we have to find out the value of phi r magnitude. So in this case phi 3 is 0. So phi r is given by under root of phi 1 square plus phi 2 square. So phi 1 is plus 0.866 phi m whole square plus phi 2 is minus 0.866 phi m whole square. So again this value will remain the same, 1.5 into phi m. So the resultant magnitude of the resultant flux phi r will remain the same in all the cases. Okay, that is 1.5 times the maximum flux. So now we'll find out the direction of the resultant flux. Okay, this is a reference vector. Now if you see here, phi 1 is positive, so we have to draw along the same direction. Okay, this is a positive direction of phi 1, so we have to draw a line along the same direction. This will represent 0.866 phi m. Again phi 2 in this case is negative, so this is the positive direction of phi 2, so we have to draw a line just opposite to phi 2, so minus 0.866 phi m. So now we have to develop this as a parallelogram. So we have to draw a line parallel to this and another line parallel to this one. So drawing two lines parallel to each other, we can obtain the resultant. So now this is the direction of the resultant flux phi r. So the magnitude remains the same, 1.5 times the maximum flux. So initially in case 1 it was here. Okay, it was somewhere here. Now it is shifted. So now we'll derive for case 3. So in case 3, we have assumed omega t is equal to 120. So we have to substitute omega t is equal to 120 in phi 1, phi 2 and phi 3 equations. So phi 1 is phi m sin omega t. So phi m sin 120. So plus 0.866 phi m. So phi 2 is phi m sin omega t minus 120. So 120 minus 120 sin 0 will be 0 here. And similarly phi 3 is phi m sin omega t minus 240. Omega t is 240 here. So 240 minus 120. 120 omega t is 120. So 120 minus 240 is minus 120. So sin minus 120 is minus sin 120. So this will give you minus 0.866 phi m. And now the resultant flux is under root of phi 1 square plus phi 3 square, because phi 2 is 0 here. So the answer will remain the same. So again we'll get the magnitude as 1.5 phi m. So now we'll draw the vector diagram. So in this case phi 1 is positive, so we have to draw along the same direction. And then phi 3 is negative. So phi 3, this is positive phi 3, and we have to draw it in the opposite direction. Okay, so first we'll draw phi 1. Okay, this is 0.866 phi m. So next we'll draw phi 3 minus 0.866 phi m and the resultant. Okay, if you see here again it has been shifted to another 60 degree. Okay, so each and every time if we vary the value of theta, the resultant flux phi r is keep on shifting by an angle, what we have assumed. Okay, we have assumed the angle at an interval of 60 degrees, so it is shifting by an angle of 60. So if we have assumed some other angle, say 40, so it will shift by an angle of 40 degree at each assumed interval. Okay, so thus the flux, resultant flux is rotating in nature, its magnitude remains the same. Okay, so now we'll derive for case 4, theta is equal to 180 degree. So substituting in phi 1, phi m sin 180 0, substituting in phi 2, phi m sin 180 minus 120 will give you plus 0.866 phi m. Similarly for phi 3, phi m sin 180 minus 240 will give you minus 0.866 phi m. So now the magnitude is given by, so in this case phi 1 is 0, so under root of phi 2 square plus phi 3 square. So on substituting and simplifying, we'll get 1.5 phi m. So the magnitude is same. So now we'll draw the vector diagram. Here phi 2 is 0, so we can neglect this. Phi 1 is 0, and then phi 2 is positive. So phi 2 positive means we have to draw along the same phi 2 direction. Okay, so and then phi 3 is negative, so we have to draw in the opposite direction. Okay, so now the resultant vector. Okay, we have to draw this parallelogram, line parallel to this one and line parallel to this one. So now the resultant phi r gets shifted to another 60 degree. Okay, so each and every time if we vary the angle omega t, okay, the resultant flux phi r will shift by an angle, shift by that particular angle. Okay, so here we have assumed 60 degree interval, so it gets shifted by 60 degree intervals. So the resultant flux is always rotating in nature, its magnitude will remain the same, 1.5 times the maximum flux. So now this is a summary of what we have discussed so far. So in case 1 we have omega t 0, phi 1 0, phi 2 negative, phi 3 positive. Okay, in case 2 omega t 60 degree, phi 1 positive, phi 2 negative, phi 3 0, and case 3 omega t 120, phi 1 positive, phi 2 0, phi 3 negative. Case 4 omega t 180, phi 1 0, phi 2 positive and phi 3 negative. Okay, so we'll see the quickly see the vector diagram how we have drawn it. So for the first case we have to draw phi 2 negative and phi 3 positive. So phi 2 negative means this one, phi 3 positive and the resultant. Okay, this is the resultant and the magnitude is 1.5 phi m. So in case 2 phi 1 positive, phi 2 negative. So here and here. Okay, so positive, phi 2 negative. Okay, this is the resultant. So this was the first position. Now in case 2 it has been shifted by an angle of 60 degree. Okay, now for case 3 phi 1 positive, phi 3 negative. So this is positive and phi 3 negative means opposite direction. So now the resultant will get shifted by another 60 degree interval. Okay, this is for 0, this is for 60, this is for 120. Okay, now the fourth case is omega t 180, phi 2 positive, phi 3 negative. So phi 2 positive means this one, phi 3 negative means opposite. Now the resultant will get shifted by an angle of 60 degree. So this is how the magnetic field will be rotating, and its magnitude remains the same in all the three cases.